You understand my point? Yes. So if you don't want emergencies and you don't want corrective maintenance in your building, please try your best to avoid every form of reactive or unplanned maintenance. We employ you to go for the planned maintenance where we have the preventive and the predictive. The preventive are just normal steps you need to take. I will give an example. For maintenance of a generator, they will tell you every 250 hours the generator needs to be serviced. Does it mean that we are going to service every 250 hours? Every 250 hours means when the generator is running. That is when it could be 1 month, it could be an interval of 2, it could be an interval of 3 months, depending on how you have PACN supplying you power supply within that environment. But for a preventive, you've already created a standard of 250. But we have what they call predictive maintenance. This predictive maintenance involves using a graph, charts, to be able to determine the performance of an equipment. If the equipment is derailing from the normal standard, you see it on your graph, you see it on your chart, and you immediately carry out what they call the predictive maintenance. And when you practice predictive, we are going to have what they call reliability-centered maintenance, then condition-based maintenance. Then under preventive, we have the constant interval, then age-based, then imperfect-based maintenance. Then major focus on facility management system. When you enter into the facility, there are 3 things that you must take into consideration. The people that use the building, which include you, your staff, and your client. Then the process, what are they doing within the building? Then the place, the location of the building also matters to you as a facility manager. These 3 things need to be taken care of. Then why do we need to maintain our HVAC system? You maintain your HVAC system to create comfort for your occupant, improve the air quality within the place. If you say, how does air conditioning system improve air quality within the space? Every air conditioning system is packed with a design filter. That filter removes dust within the space. The other 2 things you can use to clean your space is either you use a vacuum cleaner or your janitorial staff cleans your office always. But don't forget, there are some tiny dust within the air that normally cannot be cleaned. But your air conditioning system, through the filters, take care of the dirt within the air. And also don't forget, there are some building you enter. Immediately you enter the building, after spending up to 2-3 minutes, you start sneezing, you start coughing, meaning the building is infected with all kinds of airborne disease that could follow you back home. So in a building, a facility manager or a facility personnel need to ensure the quality of air within a space is at optimum, and your AC needs to be on at all time. Then it saves money. When you maintain your equipment, you avoid emergencies. And emergencies can be very expensive, because if you call a vendor that you need to fix your AC, they are having meeting now, it will tell you, Oga, you go pay express money. You are paying more for what you should have prevented. So because you want your boss to be happy, you pay that amount for servicing. And this, don't forget, will encroach into your operational cost. Then to reduce total breakdown, that should be total breakdown. When you don't maintain your equipment as at when due, expect breakdown at any time. To prolong the system lifespan, any equipment you maintain constantly, you increase the lifespan of that equipment. To reduce noise, there are some equipment, when you don't maintain them, you start hearing all kinds of noise, vibration from the equipment. So periodic maintenance and periodic cleaning ensure these vibrations are at minimum. To keep the humidity and the temperature within regulated amount, there is a standard humidity required within a space and temperature required within a space. If all those things are not followed, you will not enjoy the equipment you have maintained. To improve efficiency of our electrical system, when you don't, your filters, when they are clogged, you put more pressure on your fan, and that gives an increase in current, and that current can actually destroy your fan within your AC. And your fan is on another equipment too that is expensive to buy. Then your compressor too can be affected in the process. Then to keep our data center running, if you look at all our banks today, what keeps bank the strength they have is their data center. And each data center is built with an AC. There's no data center you have today without an air conditioning system. If you don't have air conditioning system within that place, your data will shut down. And this can have a direct effect on your customers. Because when your customers want to make withdrawals using their ATM, and the system is malfunctioning, they cannot withdraw, and they experience this the first time, the second time, sooner or later you see that people will start pulling out. So your equipment maintenance has a lot to do with your running business, with your running cost of your business and the business at large. Then what is HVAC system? A lot of people hear air conditioning system, people hear about refrigeration, they hear about a lot of things. Here, we emphasize on HVAC system. From the HVAC system, the H there stands for heating, the V for ventilation, and the AC itself stands for the air conditioning system that we all know, which is used to maintain or control environment within a building for the occupant for the process being conducted. To maintain the environment, the HVAC system controls some factors. In order for you to get the comfort that you are providing to your client, you must ensure that the temperature is within required standard. If the temperature is too low, people feel too cold and their productivity is affected. And if it is too hot, it affects also, because you see them pulling their shirt, and it could affect their productivity also. Humidity, when we talk about the humidity, you might ask, what is humidity? This is the amount of water in air. You understand humidity more because presently, as I'm speaking to you, we are experiencing what they call harmattan in Nigeria. That harmattan is telling you that we have little or no water in air. So what does that lead to? Drying of your nose. Any clothes you wash at this present, it gets dry faster. But don't forget, when your nose gets dry, all the airs within your nose too will get dry alongside. So it gives room for more dust to enter through your lungs, and this gives you some airborne diseases. So within a facility you are maintaining, you should ensure that your humidity is within a regulated standard. Then air distribution. Your air conditioning system has a fan that blows the air that been conditioned by your system to the required space. You understand? So air distribution too matters within the space. Then air quality. Air quality also matters because your air conditioning system ensure a purified air within that space. Air velocity. Air velocity also matters. It tells you if the air velocity is much, there's every tendency that the air that is moving through duct or moving through a system will be producing noise, and noise is not required within a space. Then noise level also. Your air conditioning system is required to be within a required noise standard. If it is not within that noise standard, it is not going to be okay for those people using that thing. So there are some offices that is required to be 100% silent. You can't be providing comfort and yet they are complaining of noise. People will move into the library if they have, or people will move into their phone booth or in a quiet place where they can assimilate. Then the next page. Here we have the basic components of air conditioning system, and they are clearly stated there. This is how your air conditioning system look like. You have the compressor, which you can see under there. You have your outdoor unit, which is just below here. Anywhere you see red line means the suction line. The suction line is always the red part, while the blue lines is the liquid line. So from that up there, you see the evaporator. This evaporator is actually in the indoor unit. That is what does the cooling required within the space. While the condenser is the condenser you see with mark that is marked red is the one that you see within your outdoor unit. Is the one blowing out the hot air within the space. And the heart of all this air conditioning and the cooling of your space is your compressor. Your compressor works exactly like human heart, where you have the vein, you have the arteries. Something is carrying the blood out, something is also bringing the blood in. So there is always a circulation, and the pipe must be closed. And don't forget, your evaporator comes with a fin. The evaporator comes with a fin, and your condenser coil also comes with a fin. Oh, I've moved further than what I'm supposed to be. Sorry for that. What page am I? Sorry for that, please. Oh, I'm almost there. Oh, okay, I think I'm there now. Compressor. Hello, can anybody hear me? Okay, sorry. I think I've over scrolled to some page. I'm almost there. Okay, I'm almost there. Okay, I think I'm there now. Okay, so the next page I'm intent to go to is this page. If you see this page, you see the basic working principle of air conditioning system. Please, you need to listen attentively to this. There's nothing so spectacular or difficult in air conditioning system. All you need to know as a facility manager are the major components within the air conditioning system. If they go faulty, what effect do they have on the general cooling system within your space? If you look at this space, first of all, you have your what? Your compressor. Your compressor is always energized. You connect it to electricity. When you power on, your compressor has a liquid they call the refrigerant. The refrigerants are fluids that has the capacity to cool or refrigerate. So what do they then need? Before now, human being look for a local way of bringing cooling to the environment. If you check the world at large, you see that the world, we have areas where we have cold, we have areas where we have area where we have cold, we have area where we have heat. So in those days, what they do, they go to regions where they have ice. They cut this ice, put it into coolers or preserve them and take them to where it is required. But as technology advances and innovative idea comes by, people now look for another way to ensure that people are cooled without traveling far distance to where we have ice, cut them and bring them to land. They now discover a mechanical way. The mechanical way is what you are seeing in front of you. The AC has 4 basic components. Please don't forget 4 basic components. You start with the compressor, the condenser, the evaporator, the expansion valve, and the evaporator. Don't forget, I always tell my students 2C's and 2E. The first is the compressor and the next one is the condenser. I will use energy diagram to explain this. When you on your AC, the work of the compressor is what? It compresses. It works like your water. When you put hot water on stove or you plug your electric kettle, what happens? When water is heated, it boils at higher temperature. Are you getting my point? So when it boils at higher temperature, the gas becomes heated and the pressure also increases. There are some electric cooker, when they heat, when they have attained boiling point, they begin to whistle through the pressure of steam passing through a narrow tap. you hear that whistling sound giving you signal that the water is boiling. The same thing happens within a compressor. When you energize it, it compresses the refrigerant to the extent that the liquid begins to boil. And as it's boiling, the pressure increases. And check the direction of the arrow. And as the arrow goes, the first place it goes after the compressor is the condenser coil. And the condenser is always installed outdoors. And what happened at the condenser? The condenser is a heat exchanger. It ejects the excessive heat generated by the compressor outward. You might not understand it, but I will use a simple analogy. When rain falls in your office, you see your technician, they will get their wet shoes and their wet clothes and put it in front of your air conditioning system. What are they trying to do? They are trying to get their clothes dry because the compressor has compressed the refrigerant gas, and that has increased the temperature of the gas, and at this point the condenser is ejecting the heat out. There's always a fan inside the condenser blowing out this part. If the fan does not work, you cannot get the heat out of it. And as the fan works, the hot air blows out through the fan, then cooler air comes at the back. And as this one goes by, the temperature reduces. But don't forget, I told you at the compressor point, the pressure increase, the temperature increase. When it gets to the condenser, the temperature reduces, but the pressure is still what? Is still high. So in order for us to get the refrigerating effect, the temperature of the refrigerant and the pressure of the refrigerant must be low for us to get the refrigerating effect required within space. So the expansion valve look like your capillary tube. Most of us must have seen our old refrigerator that has something. If you check at the back of your refrigerator, you see something that looks like a swollen copper in beneath a very thin copper line. They call them the capillary tube. The work of the expansion valve is to reduce the pressure of the refrigerant. When the pressure is reduced, the condenser take care of the temperature, reduce it. The expansion valve take care of the pressure, reduce it. Then by the time it comes out as liquid, it has gained what they call the refrigerating effect. And that refrigerating effect comes through your evaporator. Your evaporator is with your indoor unit. So it's the one that blows that cool air that you are enjoying within this space. Are you getting my point? So it has a vital point to play. So as a facility manager, you must understand that 4 of these components must work at a time. No one must shut down. If the compressor shut down, it affects the operation of the condenser, the expansion valve, and the evaporator. And if the evaporator is affected, it also affects the function of all these things. So when you are talking about maintenance, all these 4 components must come to play. So I've explained that. So we have 4 basic parts of AC, which I've listed before: the compressor, the condenser, the expansion valve, then the evaporator. I hope I'm communicating. Yes, yes. The other thing you also take note of that are in air conditioning system that could also be a factor are the evaporator fan. If you check your indoor unit, there's a fan that blows. The fan has 2 functions in place. It sucks in the hot air within the space and also at the same time blows out the cold air within the space. So there is a circulation within the space. So if you want to know if your indoor unit is working out fine, you can take a very slim paper, put it at the top of your AC. Once you experience that the AC is sucking, know that that point that is sucking is called the return line. It's always at the top of every AC. While the point to which the cold air is discharged is just beneath the evaporator, it always have a covering. You understand? So normally if I'm in a class, I will have asked a question now. The question I would have loved to ask is that if you must install a filter, where will you put the filter? Is it the supply line or the return line? But I will give you the answer. the filter is always installed in the return line, because the heated air and the dust within the place are being sucked by your AC. So before it enter your AC, you need to take care of the dust in air. So when you take care of the dust, the evaporator do well to cool the air, then passes it into the space which you enjoy, and the quality of air is guaranteed. Then we have the condenser fan. The condenser fan does the work of blowing out the hot air. The condenser fan is installed in your outdoor unit, and your outdoor unit is always hot. So in order for you to get it cool, you need a fan to blow out the hot air. And as the hot air is blowing out, don't forget, your outdoor unit must not be installed too close to the wall. There must be a gap of about 200 cm at the back. If you don't leave any space, the air will not be able to suck cool air around, because as the fan is working, blowing out hot air, it needs cooler air from the environment to cool itself. So when a condenser fan shut down or get bad, the compressor get overheated, and if it's overheated, it shut down the AC. These have happened in various companies. We have experienced people that their condenser fan are not working, the compressor shut down. If you have a good system that are protective enough, your compressor will protect itself by not getting burnt. But if your compressor is not well protected, I tell you, as the fan is not working, if it get overheated, your compressor can burn down. And compressor is the the most expensive component in air conditioning system, so you need to protect it. Your electrical cable, we are talking about energizing your AC, energizing you cannot achieve it without a proper cable. And I can boldly tell you that one of the best cable in the world are Nigerian cables. Though I'm hearing now that we have fake Nigerian cables, but a Nigerian cable, the original, is very good for your AC. Either you use 2.5 mm square to give you a full guarantee. And don't forget also, once you buy an inferior electrical cable, they are one of the cause of fire in the world today. Most buildings that start in high-rise building, most always come from air conditioning system. When people don't put off their ACs when they are leaving office, they don't put off their AC when they are sleeping. So you need to be careful while selecting your cables for AC. Then your electrical plug. Your plug also is the one that that is attached to the source of power. But for AC, we recommend 15 amps. We don't recommend 30 amps because you don't know when it will burn. Then we have, for some bigger system, we have what they call a dryer. The essence of the dryer is to ensure that the refrigerant gas passing through the systems are dry. They are not wet. If they are wet, there's every tendency there will be corrosion. For those of us that are engineer, corrosion means rusting, rust of iron within the system. Then we talk of side glass in big system. Side glass is for you to see that the refrigerant passing through the system is actually dry. They have color code on the side glass. If it gives you a particular color, you know it's will dry. If it doesn't give you, you know that the refrigerant within the system is not good enough. Then we have what they call the temperature sensor. This one is always connected to your evaporator. When you are increasing the temperature, you are reducing the temperature, this is the man you are talking to. Then we have your thermostat. You want to feel like a big man. Sit back and watch while you watch your football match. Your remote control is at your hand for you to command your AC to work. Then capacitor, very, very important. This give power to your compressor to work. If you don't have capacitor, there's every tendency your compressor will not work. And don't forget, when we talk about compressor, we have what they call starting current and running current. Starting current for your compressor are very, very high. It can, if your compressor is having up to 20 amps, when you are starting them initially, the amps that they draw can be as high as 30 amps or 40 amps. So in order for us to boost your compressor, you need a capacitor that will store enough electric charge to boost up your compressor as it works. Then type of air conditioning system. You might ask, Why do we have all kinds of air conditioning system? The kind of building that we live in determine the kind of AC we use in it. If you live in one single room, you see most of the single room are either having split unit or window unit. Window unit is the cheapest form of installation you have. It's just your electrical cable and your plug. But once you go for a split unit, that is, you have the indoor and the outdoor, you will now need an experienced person to install it. So we need to understand all these components to know the kind of maintenance that we need to ascribe to it. Then here we are having non-ducted product, and we have here ductable product. Non-ducted product are the split unit. Your split unit that you are using in your house, you don't need any kind of duct to make it bring out the cool, the hot air, the cool air you require within space. Once you plug it, it begins to cool. But there are some systems that are central, like chiller system. Once you install them far off, you need a medium to transfer the cool air from area where it is generated to area where it is needed. In most high-rise building today, like if you go to the VI, you go to Ikoyi, go to Lekki, and most of them are on central unit. This central unit need what they call a ducting system. This is another form of HVAC that is very broad also. So we will not speak more on it. What is required is just know that we have a ducted unit and we have non-ducted unit. Under non-ducted unit, you have your split unit, you have your window unit. Then under your split unit, you have the floor mounted, you have the wall mounted. Most floor mounted are used, if you go to bank, you see most of those floor mounted in banks. Those ones standing as high as as tall as human being. Then we have the wall mounted, those ones that are you hang on top of the wall. And we also have the ceiling mounted. There are some units that also work like split, but they are mounted on the ceiling. You understand? Under the ceiling, we have the exposed type, the hidden type, and the cassette type. Most fashionable hotel today, they would rather go for this cassette type. That cassette type will just be on your ceiling. Nobody will notice that it's air conditioning within your space. Then we'll go to this other one. The ductable units are packaged air conditioning units, or they are like self-contained. Everything is built together. Then we have what they call central plant. Central plant is like chiller system, your absorption chiller, and the rest. Then here under the package unit, we still have another floor package air conditioning unit. Those are bigger units. They use them in industries, in commercial areas, not in hotels. Then air cooled ductable unit also work exactly like the split, but after it work exactly like the split, but this type, the indoor units are now ducted to deliver air where it is required. When you are designing for an open space, you don't want air conditioning to be littering every space. So you decide to use either one or two. Then you now duct it by virtue of diffuser station at different points. You solve the problem of distribution. You understand my point? Then under the floor mounted, we have the air cool and the water cool. Then under the central unit, we have what they call the DS system, and we have what they call the chill water system. So then we have the vapor compression unit, then we have the vapor assumption unit. I will show you this as we progress along. The vapor compression unit is what I've initially explained. The vapor assumption unit uses another form to cool air conditioning system. As you are thinking of air conditioning system, also think that most of the systems you see presently are used in buildings, they are used in factories, they are used in industries, used in hotels. Have you ever asked yourself what kind of air conditioning system will be used in aircraft, aeroplanes? What kind of air conditioning system will be used in submarine? What kind of air conditioning system will be used in rockets? Are they going to be split unit? Are they going to be this? There are new technology that have been fashioned, designed to suit every purposes. What you are seeing presently in industry, and these are the common one or the common type you know. There are other type of air conditioning system you will meet as time progresses. The latest one reigning in Nigeria today is what they call the VRF system. We'll talk about that too later. Then this is the common type, the window unit. I call it the student unit. If students in school want to buy AC, these are the one they can afford. Some can afford split, but this is the cheapest. You don't need an installer. Just buy your electrical cable 2.5 mm square, buy your 15 amp plug, put your thing there, the AC will answer you. So when can we use this? Where can we use this? This can be used in school, higher institution, hotels. There are some cheap hotels that cannot afford bigger units, so they go for window units. Then hostels, then residential apartments where people live. They also make use of this. Then some offices that cannot afford to buy bigger units, they go for this. And don't forget, this unit always come with what they call R22. R22 is one of the refrigerant used today. Because of their effect, their devastating effect on the environment, they are no longer in production. They are no longer in production. Oh God, have mercy. They are no longer in production. Sorry, hello? Can you hear me? Hello? Okay, they are no longer in production. So only few quantity are being produced compared to about 10-15 years ago. You understand? So I would not recommend you tell your client to buy this kind of equipment unless it is residential or they insist they should buy it because they come with R22. Then this is the most common air conditioning system we have in our building today. Every design is fashioned to do this. The problem this window unit creates is that when you want to install it, you have to break a wall and buy what they call burglary to put at the back. And we've discovered that if you stay on the ground floor, there are some people that are smart enough. They've been able to cut off their burglary, and people pass through the burglary, carry whatever things they want to carry. So we don't want such. So people look for another way to design just a system where you have just a little opening in the wall, which you can see on this other one. Just little opening on the wall, and your indoor and outdoor is connected. You understand? So we already know where we can use it: our homes, offices, school, higher institution, etc. Then we have the cassette unit and we have the ductable unit. The cassette unit they work like the split unit, but they are the fancy type. They are expensive. This problem of leakage is also considered. This cassette unit you are seeing has a pump that can take water from a lower level to a higher level. So that's why a lot of hotel that want something fancy, they've gone for this kind of design. There are some that will tell you they don't want cassette unit because maintenance is always an issue. Or with time, the white cassette will be, the white surface will be turning milk. They want something hidden. So those one go for what they call a ductable unit. The ductable unit is always in the ceiling and it is ducted out to where it needs to cool. Sometimes these outdoor units, you see them in double volume. This one, depending on the quantity of load or heat load they need to take care of. Then this is also another ductable unit. You can also, this is a ductable unit at the top, but this other one is a fan core unit. They work exactly like your split unit. The only difference is that their design accommodate them to be inside the ceiling. You will cover everywhere. You only duct it out and use a diffuser to distribute the air within the required space. Then we have what they call package unit. When you hear package unit means all the components I've mentioned to you earlier: the compressor, the condenser, the expansion valve, and the evaporator, all are in one component. That's why they call them package units. You know, when we're in school then, we students that don't want to stay in private, we tell the owner of our property that we want a self-contained. So you can call this man a self-contained air conditioning system. And from this part, you see what is happening here. The cooler part is at the top, while the heated part is at the down. So when you see the red line, you know that that part is the condenser or the outdoor unit, while the one that shows blue is the cooler part. You see, the hot air comes through this place, comes through this side here, through the return, while the cool air is blown out through this region, ducted to the required space that it will be needed. Then where can we use it? You know, as the size of a space increases, you must ensure that the required AC accommodate the cooling. I give you another example. I've been to a bank, most especially, sorry for calling names, First Bank. During the week before salaries are paid, you discover that the banks are cooler. But immediately salaries are paid, you see a lot of people coming to do transaction in the bank, most especially banks in remote areas that you have a lot of people. ACs are working, but the number of people within the space has made the AC inefficient. So sizing of your air conditioning matters a lot. It matters a lot. Don't just look at a building and say you need 1 horsepower here, you need 2 horsepower here. You must calculate. When you calculate, you will determine the energy required to power the AC. You also determine what is needed to install the AC. If you get a bigger unit, you pay more for electricity. And if you get a lower unit, you will make your client feel discomfort. And if you feel discomfort, it affects your efficiency. You get my point? Then these are the big air conditioning system. These ones are used in halls, big spaces like the stadium, auditorium. Where do we have event centers? Areas that you have large number of people doing parties, church services, mosque services, and the rest at a go. And you don't need to put about 20 to 50 split units. You just want a central point. Then you go for what they call a central unit. And I explain something to you. When you hear air cool chiller is using, it gets its name by the method of cooling the condenser. It cools the air cools the condenser. When you now hear of water cool chiller, they use water to cool the condenser. That is how they derive their names. So this is an absorption chiller. This chiller you see here is one of the chiller actually delivered in parts in Ibadan. They bought about 2 of it. Each of these chiller you see, they use it in factory. It works more efficiently than the air or water cool chiller I just mentioned to you. One of these is close to about 50 to 60 million when they bought it then. And it work with heated the hot steam coming in from their generator powers this, and through this it cools, and it cools all their latest equipment they bring in into bath. So it's not a regular thing you see unless you work in the factories before you see this kind of air conditioning system. Every other one I've mentioned before, you must have seen it or you must have heard about them. But this is not too popular in Nigeria. You only get them in factories. Then we have another system I mentioned earlier. They call them the variable refrigerant system. What do? The variable refrigerant system put together some ideas of a central system and ideas of a split system. They combine them together, modify the kind of compressor, and bring it to life. The V stands for variable, the R stands for refrigerant, then the F stands for flow. In other form, you can see them as VRV. VRV is variable refrigerant volume. They mean the same thing. The benefit of this system is that it saves energy. It has multiple compressors that works together. They sense the heat load coming in to the compressor, and as they sense the heat load, what do? They reduce the number of compressor working. If we have 1 or 2 person within a space, this system has the capacity of shutting down multiple compressors and now allow only one compressor to function, meaning you are working less. You get my point? So most building today are going for refrigerant flow. But I must warn you, if there's a leak, you can see that everything is centralized. All these red lines you see are copper pipes. If you get an installer that does not know how to install a refrigerant, you're already in trouble, because a leakage at any point will affect the whole system. So you must get it right at the very first time. If not, you have bought a problem for yourself. Then we also have other type of HVAC system, not listed in this presentation, but are used in various sectors. Have you ever asked what type of AC are used in a submarine, used in the ship, used in planes, used in rockets, and many others? I've mentioned this earlier on. There are different kind of AC used in all those sectors. How do we maintain this air conditioning system? All these air conditioner systems that I've mentioned have various ways of maintaining them, but the basic things you need to focus on maintenance are the compressor, the condenser coil, the expansion valve, and the evaporator. So I go to the compressor. This is how one of the common compressor look like. We have various type of compressor. We have the screw, we have the screw and the screw are the most common type that we have. You understand? They have the reciprocating compressor also. But this screw and screw, you see how it is. Something rotates within the compressor. And as this thing rotates, you understand, the gas is being compressed. Are you getting me? You see how the red arrow is going out. The refrigerant entered through this point here. As it entered, this thing energized it and it sent it out as a hot air at that point. So very, very important for you to know. You might not know all the parts of a compressor, but just know that the compressor is the heart of your air conditioning system. Then, okay, I've listed it here. These are various type of air compressor that we have in AC, and each of them are employed to handle the particular heat load required to cool either a building, hotel, factories, commercial center, event center, stadium, auditorium, and the rest. So they have their various purposes. What is important to us are ways by which we can maintain them. Why compressor goes bad? When you have low refrigerant in your compressor, it can damage the compressor. Just like human being having low blood pressure. If you have low blood pressure, it's a serious thing. And if you have also high blood pressure, it's also a serious thing. The same analogy can be used for the compressor. Poor ventilation. You remember when I was talking about outdoor unit, I told you the outdoor unit must not be installed too close to the wall. Once you install it too close to the wall, you destroy the compressor. Block suction line. Within the suction line, as the hot air is going, if they are decked within your AC as it's working and there's a blockage within it, it will shut down the whole system. It will not work. That's why when you get an installer, ensure that when they are brazing, no particles of copper are left inside the copper pipes that are used to connect all these components together, because all those particles, they will go to a particular location and clog the movement of the refrigerant and thereby shutting down the system. If you do not have that experience, you might not know what the problem is. Poor power supply can also affect, and this is a general problem in Nigeria. That's why you see that most companies rely on diesel generator. High voltage supply could also affect your compressor. If your compressor does not have what they call AVR, automatic voltage regulator, there's every tendency that high voltage can go into your system and burn out your compressor. Poor to bad installation. If your system are poorly installed, it can also affect your compressor. Factory problem. There are some AC that comes with inbuilt problem. If it is not checkmate from the beginning, then you have inherited a problem. Bad capacitor. When your capacitor, when you put high voltage, if your capacitor is overcharged, you see that it will swell. And if it swell, it shows that the capacitor is getting bad. And once it gets bad, it cannot power the compressor for you. The wrong pipe size. You must use the required size of pipes for your compressor. Where they mention 1/4 inch of a pipe, do not use 1/2 inch. When they mention 3/4 of a pipe, do not use 1/2 inch or 1/4 of a pipe. So that is a warning. Then solution, ensure the refrigerant is within required standard. When you are charging your system, there's a particular pressure that it must attain before you know that the compressor has gotten the required refrigerant. If it doesn't get it, then you are not good to go. You can't commission your AC. Provide good ventilation. That should have been ventilation. Then clear sunshine line. During installation, ensure your sunshine lines are clear. Ensure good power supply, or install what we call AVS or AVR. Good installation. When you want to install AC for your client, ensure you use a good installer. Don't use that Kamaru by the roadside or a maker passing by the roadside. Get somebody that has the experience of this thing. If not, you have problem. Ensure your product have warranty. Sometimes we rush to the market and go and buy AC. We say this one is cheaper, this one is good, this one is that. Please, I will advise you, if you buy AC that has warranty, there's every tendency, if it come with factory defect, it can be returned. Then install good capacitor. Once you discover that your capacitor is bad, if you can remove the capacitor, just check the number written on it. If it is 3 UF or 5 UF, normally it's supposed to be microfarad. But when you go into the market, the Igbo boys will call it UF. That is what they understand. They don't know what they call microfarad. You understand? So when you go to the market, you buy equivalent of the same capacitor, replace it, and your AC is good to go. Use the right copper size. So you are not a technician, but if you want to detect a faulty compressor, first of all, you test for continuity because it has electrical power running to it. You must test whether it's reading to earth. So your electrical person can handle that for you. So once it's reading to earth, you know that it is fault. And when the compressor is no longer being powered, you will know. Sometimes when you use your tester to touch the body of your compressor, you see that light is your lighter brings out light. That compressor is gone. Either some cables have been destroyed or melted inside, touching each other. That's why it's bringing all those things out. Go to the next one. Then your condenser. This is how your condenser, the outdoor unit, this is how it looks like. You see the fan there? You see this thing that goes round. It has copper and it has aluminum fin. Then the compressor is sitting somewhere here. So this is the powerhouse, and you have you see the capacitor on top of this place and the electrical cable connecting them together. You understand what I mean? So we'll go to the next page. Common problems with condenser coil: block coil, bent copper fin, poor installation on leaked coil or leaking coil. Block coil. What do we mean by block coil? When your condenser is working outside, you now see that your technician carried a long sweater that is wet and cover the outward flow of heat. You are increasing the temperature of the compressor. That could damage the compressor. The method of installation could also affect. When you are installing your AC, ensure the forward discharge. Just ensure the forward discharge of your AC is a minimum of 1 meter away from the point of installation. Do not install any unit at 500, 900. It must be at minimum of 1 meter. That is 1000 mm away from it, so that the hot air can get itself out. Then some cool air can come and cool it. Then bent copper fin. Your outdoor unit has some aluminum fin. The essence of the aluminum fin is to encourage effective distribution of heat. round the copper pipe. So if they are bent, as air is being sucked around the condenser coil, it will not find way to blow out the hot air. It will bounce back into the unit. This could also affect the compressor. Poor installation too. When you install your unit and face the wall, there's no space. Or there are some architectural building that you see, they will build it in a way that the ACs are, the frontage are blocked. There's one I saw in Bodilon. The AC was initially working during rainy season. Such AC used to work, but during dry season where everywhere is hot, the AC need cool air around it. It doesn't need hot air. You now build, you put it in a bank. The bank does not have areas to which hot air can go, so the unit itself trap heat within the bank. So as the AC is blowing out hot air, it's still sucking the same hot air. Within 10 to 20 minutes, the unit shut down because it needs cool air to cool itself. You understand? So your installation matters a lot in air conditioning system. Okay. Then leaking coil or leaked coil. Sometimes when you buy your AC, the way they package, the way they bring it could also affect. There could be a defect in the copper pipe. If there's a leakage along the copper pipe, you understand the unit will definitely will work for a while, then shut down. That leaking could be also likened to somebody having internal bleeding. You understand? Once an AC has a part, you have put it to be working at 30 pascal as the pressure within. And if there's a leakage, that pressure will begin to drop. So the AC will not work effectively again. You will hear one of your technicians say, Oga, make we top am up, make we top am. How long are you going to be topping the AC when you have not been able to detect where the problem is coming from? So you need to detect it and block it. Solution: clear block coil with pressure washing machine. So what do you do if there's a block? Your one other thing I did explain. Your block coil could be due to the environment you store your AC. If you install your AC in a very dirty, dusty environment, there's every tendency that the AC will suck in dust. And if it's sucking dust, time will come. The AC will now act like a solid object. It will not allow air to go out, neither will it allow air to come in. And this increases the temperature of the compressor. So the only way to get it solved is to use what they call a pressure washing machine. The pressure washing machine is also used in washing radiator. You understand? So your car radiator. So once you blow out all the dust within the AC is new all over again. So most companies decide to buy and have it on site, while some other decide to rent. But some they use normal host. Connect hose to the pipe, to your tap, then use your hand to press the front of your hose and you pressure wash, but it will not be as effective as a pressure washing machine. Ensure the fins are not bent. Don't allow your fin of your outdoor unit to be bent, because if they are bent, they could be returning the hot air back into the system. Good installation, I've always mentioned it in others. Then block any leakage. If there's a leakage, first of all, pump down. Once you pump down, get your technician in to look for the leakage. Either they use soap water or a leaking gas detecting equipment. Once you get that done, once you identify the location, you can now brace. When you brace, you can now power up your system. Then expansion valve. This is how the expansion valve looks like. It is very, very thin. So poor installation can actually affect it. If you install and you have some debris inside your installation, they could block the small copper pipe that is supposed to reduce the pressure. And once that is blocked, the other thing you can do is to change the expansion valves. So see, this is what it looks like. You must have seen this before. So that is what it looks like. Then Common problems with the expansion valve: poor installation. I've talked about the blockages from poor installation. Poor phase change from compressor. When the compressor does not change from suction to liquid, then the problem becomes then when you use fake, if you go to the market, we have a lot of things that are fake. So I always recommend you as a facility manager to have a certified vendor for all your product. If not, sometimes to determine which is fake and which is original might be difficult. Then solution: good installation, proper phase change from compressor, and use the right component. That is TVS. That TVS stands for thermostatic expansion valve. Thermostatic expansion valve. But the normal name is expansion. When they say thermo tends to do with heat. So it responds to heat change. Then this is your evaporator. They come in different form. This one you see it in bigger units, while this one you see it in your evaporator, the one you have indoors. Then what are the common problems with the evaporator coil? They have block coil, just like they are like condenser too. Then you have low refrigerant, you have faulty fan, gas leakage from its coil, then factory error. Possible solution: clean or pressure wash the coil, ensure required refrigerant is in the unit, ensure the fan is working as required, seal off the leaking gas, then make use of your warranty. Once you notice that your evaporator is giving you problem, you employ your warranty so long it's within the period of the warranty. Then other component that needs to be taken care of, which is the most important thing towards the quality of air within the space, is your filter. This filter also works exactly like our nose. If you check your nose, there are hair just around your nose. What does the hair do? They try to block dust going into our body. The same way with your filter. Any dust going into the unit is the first point of removing the dust, getting a purified air across the coil, and supplying you with the required cooling. So common problem with filter: block filter. What can block filter? Dirt, dust, poorly installed filter. When your filter, instead of using the proper size, you went to buy filter that is half. So you left the other part of the unit to be working while half part is with filter. So there's every tendency that the evaporator or the condenser could be clogged. Low quality filter. There are some quality of filter that are low in the market. Then using the wrong filter. When you are not using the appropriate filter, then there's every tendency that the air quality you are trying to guarantee within the space will not be okay. Then solution: clean filter. How do you clean filter? You use pressure wash. After you remove it from your AC, use water to wash it, pressure wash, then dry them in the sun. But approve that works with it. You use that required one. Then air conditioning leakage. Air conditioning leaking. So this is a major problem. This is a major problem in the facility. You come from the office, see that most of us are wet, or you see your drain outdoors are wet, or you start seeing around your air conditioning system. It has to do with what? Water, either from the drain line or from the evaporator. So in installing your conditioning system, there's always a hose connected to all take that water, drop from your evaporator out of the building. Then it needs to be installed properly, so that there will be forward flow of water out of the building. So if no forward flow of water, the back flow. Central unit, we design the drain using what we call the yes, Not a break.
Hear you again.
You can't hear me now.
Is it free?
Hello, can you hear me? Can you hear me? Can you hear me now? Can you hear me now?
Okay, let me check.
Eh, Can you hear me? Hello? Hello?